Hi, my name is Cynthia Smith, and I'm the Executive Director and Chief Medical Officer for the National Marine Mammal Foundation. Today, I'll be presenting on marine mammals and respiration, evidence of poor pulmonary health in bottlenose dolphins following the Deepwater Horizon oil spill. I'd like to thank my co-investigators at the National Marine Mammal Foundation, NOAA, the University of Illinois, Chicago Zoological Society, and Bayside Hospital for Animals. The Deepwater Horizon oil spill caused large-scale contamination of bays, sounds, and estuaries in the northern Gulf of Mexico. The oil spill footprint seen here on the left overlapped with the known ranges of 21 species of dolphins and whales. The spill caused one of the longest lasting and deadliest dolphin mortality events in the Gulf of Mexico, based on ruling out other potential causes. The event lasted 4 years, and more than 1,000 animals washed up dead, from Louisiana to the Florida Panhandle. Previously, scientists believed marine mammals would avoid oil, but that did not prove to be true. And hundreds of animals from at least 10 species of dolphins and whales were documented swimming through oil with no evidence of avoidance. Marine mammals were likely exposed through multiple routes, including inhalation of vapors and aerosols, direct aspiration of liquid in droplets, ingestion with or without subsequent aspiration, and dermal absorption of oil and its toxic components. It's worth noting that dolphin lungs may be particularly susceptible to the negative impacts of inhaled or aspirated chemical contaminants. And this is due in part to the way they've evolved to adapt to being in an ocean environment. They have a straight, rapid intake of the surrounding air directly into the lungs without protective cilia or nasal turbinates to filter things out. They also have a very large volume of air that's exchanged. 90% of the air they breathe is exchanged with every breath, and they have an extended breath hold. And they also have double layer capillary beds that enable an efficient movement of airborne compounds into the blood. So all of these different adaptations may make them more susceptible to chemical contaminants. Marine mammal behavior may also increase the risk of exposure. And we conducted studies in Baritaria Bay where satellite tags were attached to the dorsal fins of dolphins to track their movements. So each of the dots here on the right side represents a dolphin that was satellite tagged and their location at a specific moment in time. The study results showed us that Baritaria Bay dolphins have what's called high site fidelity, which means that the animals tend to live in the same region for multiple years and they are unlikely to leave. As part of the natural resource damage assessment conducted by NOAA of the Deepwater Horizon oil spill, dolphins were included in order to characterize the injury that occurred and also quantify the amount of restoration that would be needed to mitigate the negative effects of the spill. Multiple adverse health effects were documented in bottlenose dolphins that were living within the oil spill footprint. And these included a high prevalence of moderate to severe lung disease in both live animals examined through capture release health assessments, as well as the dead animal investigations of animals that washed up on the beaches. We also documented an impaired stress response, which was characterized by a prevalence of low cortisol in animals in the face of a capture release event. And in the dead animals, we documented adrenal cortical thinning in the adrenal glands of dolphins that had washed up dead. We also documented an increased mortality rate and a low reproductive success rate. And in fact, in the 8 years following the spill, only 20% of dolphin calves have survived. And that's compared to more than 60% success rate in other areas of the Gulf and along the Atlantic seaboard. So today we're focusing on dolphin lung disease. And we know that dolphins living in these heavily oiled sites have had evidence of poor pulmonary health. In 2011, we documented that dolphins in oiled areas were 5 times more likely to have moderate to severe lung disease than those living in unoiled areas. In 2013 and 2014, which was with at the end of the NERDA, the dolphins were still 3 times more likely to have moderate to severe lung disease. So we did see persistence at that point. So our question for this study was in the 2016 and 2017 and 18 time period, 6 to 8 years after the spill, would that lung disease persist or would it in fact improve? So in order to evaluate pulmonary health in live dolphins, we conduct capture release health assessments. And these include comprehensive physical exams, diagnostic ultrasound, excuse me, morphometric measurements, blood-based tests, biological samples, and blubber biopsies. This allows us to piece together a very thorough picture of an individual animal's health, which then informs population health. Pulmonary ultrasound is a common tool used by marine mammal veterinarians in order to evaluate pulmonary health, and it allows for a rapid detection of disease based on established techniques. And we really are just looking at the periphery of the lung field. Unless the disease is significant and it's getting up to a moderate and severe disease at that periphery, then we can actually see, and the sound waves will penetrate deeper into the lungs, and we can see more of the organs that is affected. So in general, we consider ultrasound to be a conservative estimate. It underestimates lung disease rather than overestimates lung disease. So during our study period, 2016 to 2018, we examined 103 dolphins living in the unoiled reference site, Sarasota Bay. And 84 of those dolphins were alive at the time of the spill. And we know this from our photo ID studies and the long-term tracking that has been conducted in that bay by Dr. Wells and his group. And then we know that 19 were born after the spill. 171 dolphins were examined in Baritaria Bay, and 132 of those dolphins were alive during the spill, and 18 were born after. 21 were this borderline age where we didn't know for sure whether they were born after the spill or not, so we did not classify them or include them in the study. And then we did compare the findings between the non-oiled Sarasota Bay site and the oiled Baritaria Bay site. So we can detect several abnormalities with ultrasound, ranging from pleural effusion to all the way to pulmonary consolidation. So we can detect nodules and masses. And then I want to draw your attention to something called alveolar interstitial syndrome. And this is where fluid or cellular infiltrate works into or comes into the interstitium of the lung and results in reduced air in those alveolar spaces. So we're going to be talking about alveolar interstitial syndrome because this is something that we did see quite frequently in Baritaria Bay. And then we also score the lung overall from on a scale of normal to severe. So we have 4 different categories: normal, mild, moderate, and severe. And that will just give us another way to compare the findings between sites. So we're going to start by looking at heat maps of the different pulmonary abnormalities that were detected in both Sarasota Bay and Baritaria Bay. So on the y-axis, we have the years progressing from 2011 up to 2018. And then on the x-axis, we have the actual abnormalities. And so you can see in Sarasota Bay, the color, which ranges from light yellow, which is 0 prevalence, to dark red, which is 100% prevalence. You can see that there aren't a lot of pulmonary abnormalities that we have detected in Sarasota Bay dolphins. So I'm going to migrate this over to a Baritaria Bay dolphin picture. So just keep your eye on the colors. And you can see that we have a lot higher prevalence of abnormalities such as nodules. We have more consolidation, more alveolar interstitial syndrome, or AIS. And then we also have something that we documented in 2016, 17, and 18 in particular, which is this worsening of alveolar interstitial syndrome, dorsal to ventral. So there's a pattern to the abnormality, and dorsal to ventral meaning from their back to their belly on a dolphin. Next, we're going to look at the prevalence of moderate to severe lung disease, and we're going to start with Sarasota Bay. And so again, the lungs are scored normal, mild, moderate, or severe. And moderate and severe are the ones that we're really paying attention to. In Sarasota Bay, you can see that we do get occasionally moderate lung disease cases, but we did not have any severe cases in the animals that were alive at the time of the spill. So all of the bars are representing animals that were alive at the time of the spill, except for the last bar, which is animals that were born after the spill. And you can see that we did have um, a couple cases, a few cases in there of severe lung disease. But we're really focusing on those animals that were alive at the time of the spill and whether or not that lung disease, how it's changing over time. So if we look at Baritaria Bay, you can start to see those severe pulmonary disease cases that show up, and there are actually a lot of them. So the prevalence of severe lung disease in Baritaria Bay is significantly different than Sarasota. And then you can actually see in 2017 and 2018, this high prevalence in 2018 in particular, we're really focusing in on to try to understand what exactly is happening here. We can see the prevalence changing, but why is that, and how is the disease characterized? So one of the clues that we got was this worsening of the alveolar interstitial syndrome from dorsal to ventral. And you can see that we're looking at the prevalence or the probability of worsening AIS over time from 2011 to 2018. And it's actually, we're seeing more cases of this worsening AIS over time. We believe this is linked to a chronic progressive disease state. And so now we're honing in even more on this type of lung disease. So just very quickly, here's a case example of what one of these dolphins looks like. This is a live dolphin that was evaluated in 2011 on the left during a live capture release health assessment. The animal washed up several months later and was necropsied. It was diagnosed at the time when it was alive with severe lung disease based on ultrasound findings of masses, consolidation, and severe AIS. And then on histopath, it was also diagnosed with severe lung disease. It had severe bacterial pneumonia. So in summary for our pulmonary ultrasound findings, these findings are persisting in the heavily oiled, heavily impacted Baritaria Bay 6, 7, and 8 years after the spill. Baritaria Bay dolphins are still greater than 3 times more likely to be diagnosed with moderate to severe lung disease than dolphins that are living in unoiled areas, specifically Sarasota Bay. And the highest prevalence was actually documented in 2018. So overall, the AIS prevalence is increasing over time. And then we have this consistent change that looks like a shift toward a more chronic, potentially progressive lung disease state. So there have been numerous studies showing that exposure to toxic oil components can lead to pulmonary injury and disease in humans and animals. And in fact, respiratory symptoms following exposure have been seen in multiple oil spills in humans, and including deep water. And this inhalation exposure has actually been conducted with laboratory animals and taking particulate matter from in situ burn plumes from Deepwater Horizon, exposing animals to them, and they did see pulmonary inflammation and altered immune responses. So in summary for our investigation, we are seeing that pulmonary disease has persisted in Baritaria Bay for up to 8 years after the spill. The respiratory effects are consistent with the known impacts of oil, and they're also consistent with what we're finding. The live and the dead findings are consistent with one another. Our comprehensive medical exams have ruled out other known causes of increased lung disease in dolphin populations, such as dolphin morbillivirus. And we do need continued monitoring of Baritaria Bay dolphins in particular, which will be essential for determining the trajectory of recovery. So I'd just like to thank our collaborative GOMRI and CARMA teams. These studies take a lot of people, a lot of time and energy and effort. So thanks to everybody who has been a part of these studies. And with that, I'll take questions. Thank you.